Siis moro.
Thank you, Yoni. Thanks for the introduction. So today I'll just talk about two different hats, something similar to how Eric did, but not to that deep details. So I'll just go through about Atlas Copco. I will not talk about all the Atlas Copco products because product marketing from our company will do that better, but I'll just relate how that ecosystem is linked with standardization. So that is the part I will cover with respect to Atlas Copco. So let's get started. Uh, Atlas Copco is, or Atlas Copco devices are being used from mobile phone manufacturers to wind towers, from automobiles to aerospace. Many customers use Atlas Copco ecosystem and devices. And then there are specific needs from automotive industry and aerospace industry where they would like to have a transition towards smart factory. So to support that transition, Atlas Copco has a framework called Smart Integrated Assembly, where we have a pyramid on the left side, where the bottom level is the devices which provides a quick status. We perform a specific operation, whether it is okay, not okay, and then next level will be the quality check, whether the controller and tool are running properly or not. And then we go to the upper levels where we do the station management, production optimization, etc., and then data analytics. So Atlas Copco provides a lot of framework. But one of the key factors towards smart integrated assembly to support the smart factory journey for our customers is these enablers: OPC UA, 5G, radio modules, etc. All these are necessary for covering the smart factory use cases. So let me take a small example. In this slide, traditionally how factories have been organized, there have been devices. Every station had a fixed set of devices. But now customers would like to move, okay, I would want to have a dynamic assembly of this product in any station within the factory. So if customer has these use cases, we also have to come up with smart tools for that. In this use case, in this image what we see here, all these tools have similar capabilities. The torque range can differ from 20 Newton meter to 150 Newton meter. But the advantage here is, compared to the traditional approach, the operator can carry the tool, go to any station or near any product, and based on the context, what is the context? Maybe the location where the tool is, or the context can be the product which needs to be, where the operations have to be performed. And then based on the context, a dynamic process is selected. So what happens now? Customer doesn't have to have a fixed set of devices within a station or within a specific area. The tool can move around, operator can move around and perform the tightening dynamically. So this is how the smart factory use cases are there, and we provide smart tools to help towards that journey. So that is the context. But in all this, when I talk about context, I mentioned location. Yeah, but these data have to be exchanged. These data have to be exchanged in a standardized way. So that is very important, and that's where we will link this to OPC UA. Now, in all this ecosystem, so far since morning, we have had multiple presentations. The key thing is data, how systems are consuming or talking to each other, the interfaces. Traditionally at Atlas Copco, we have had something called Atlas Copco Open Protocol. This was again 20 years old, but it was a pretty old protocol as of now. It is used in production, it is working perfectly fine. But today's industry have much more higher demand. Security is a demand. And then Atlas Copco Open Protocol was only for tightening industry. Atlas Copco in last 10 years have acquired a lot of companies related to gluing, where we do assembly using gluing, riveting, and so on. So there are growing needs and a growing ecosystem. And cyber security or security features are not supported in the existing protocols. That is also one of the key concerns we were mentioning about hacking, where Microsoft Azure 600 million hack attempts per day, something like that. So these are the demands in the industry. So how, and apart from open protocol, we also had customer-based protocol, like customer A wants data in a specific format, customer B in the same way. So the development cost is so huge, and then integration was becoming very difficult when we want to achieve the smart factory use case. So for that reason, OPC UA stands out mutually beneficial. It is beneficial even to our customers and also to us. It is not only for Atlas Copco, but for all the vendors of the joining or tightening systems. So this is where we will talk about OPC UA within joining system context in the upcoming slides. Now I will end my hat of Atlas Copco and convert to the editor of VDMA Industrial Joining Technologies Working Group. So what is this group? Let me give a history about it. OPC UA is there from 2006 or so, or 2008 practically. But in 2018 and 2019 timeframe, some of our customers contacted us, Atlas Copco. Okay, we are interested to use OPC UA technology. Do you have an information model for tightening systems? Okay, no, we don't have. We contacted OPC Foundation to ask, okay, do you have a standard for tightening? They said no, please contact VDMA. Then we contacted VDMA and organized an initial kickoff in May 2019, where competitors and different vendors of tightening systems gathered, and the goal was to define or form a working group for tightening systems. But the good point is, during that workshop, we all thought of a much more higher vision. Why are we only focusing on tightening systems? Assembly would also include gluing, riveting, and other joining technologies. So what we did was, we created a placeholder called Joining System or Industrial Joining Technologies Working Group. But at some point, we have to start the work. Can we really generalize and talk to all or cover all the use cases? No. So we started work only with the tightening specification initially. We defined some minimal use cases, and then after 2 years, we published a first version of tightening and continuously worked on other joining technologies. When we have defined the first version of tightening specification, we spoke to some other vendors or our division on gluing and riveting, and we explained, okay, this is what we are doing. What do you think about it? They said, yeah, these models are good enough and useful for us, but the specification is called as tightening. We can't use that. Right. So now we have generalized, extended the use cases, and moved all the primary models to a base specification called joining. So with that, it covers the base for a lot of joining technologies together. So that is the history and what we have been doing. And this year, in March 2024, we have published both joining specification and tightening specification, covering several use cases, which I will go through in the upcoming slides. So as I mentioned, we have the working group called as Industrial Joining Technologies, and the base specification is 40450. And then we also have a tightening specification. So basically, these two specifications are already available. And when we spoke to the divisions of gluing, riveting, and flow drill fastening within the organization, they said majority of the use cases are covered, some additional features are needed, and in that case, if there is any very specific use case, for example, for gluing, we already have placeholder specification numbers, and we can define gluing specification and riveting. But the primary goal is not to have a lot of specific use case. The primary goal is to have a lot of use cases covered at the base level, unless it is very specific to a specific joining technology. So that has been an important vision for our Atlas Copco and even other vendors within the working group. Who are part of the working group? These are the companies who are part of the core working group, where we meet weekly. And pre-COVID, we used to meet face-to-face a lot, and now we meet once a quarter or once in 4 months, we meet in person. But we also have regular telcos, and we define the specification and additional features. But are these the only people? No. What we also try to do is, every 3 to 4 months, we try to contact several customers to get feedback, to provide the status, and to get more use cases which are needed. So we work in an agile way, where we develop some concepts, get it reviewed, and so on. So this is not limited with these names. we have a separate type of mechanism where we invite a lot of stakeholders to get review comments and so on. So this is about the history about industrial joining technologies working group. Now I will move towards the use cases and then technical overview of the models. So let's cover the use cases. These are not new use cases. These are very common. Asset management, everyone talks about it, but this is very important use case. The first entry point, yeah, this tool is there, but what is this tool? How do I identify? My name is Mohit Agarwal, but how do I identify this? Asset management, I need to know how many assets are available within the factory. I need to know what is the identification of that. If I want to have service information or do maintenance or anything, the first entry point is to understand what is available. So that's why asset management use case is very important. And then condition monitoring, of course, on top of asset management, yeah, fine. We have all these devices, but is my battery running or is my tool really running? Does it need service? So we need to monitor the health of the devices or system. So that is the second use case. And then result management is the most important use case for our domain. Why? Because if I take automotive industry, we have a legal obligation to store the result for several years, I would say 5 to 10 years at least. Because, for example, we drive cars, consider there are cases where cars are recalled. So when a car is recalled, they have to do a lot of analysis back in time. And each and every data point have to be stored for several years. That is a legal obligation in automotive. So result operation, we need to know what happened, what were the trace points, etc. So there is a lot of data which is reported from this tiny tool. I'll explain that in a demonstration. Then event management, of course, several things can happen within the system. Yeah, tool got disconnected, tool temperature is too high, tool got locked, something can happen. And those are covered in a standardized way via event management use case. Commands or methods is the way to control the system. Fine, this tool can be dynamically used. I can assemble a car seat using this, but I can also assemble a wheel. But there will be a different type of torque values needed. So I would like to select a specific process. If I'm assembling the wheel, I would like to select process 1. If I'm assembling the car seat, the configuration is different. So those type of things can be done with several commands which are defined. And then the last use case, this is for our futuristic vision. How our traditional factories within our domain are working? They say, we have 5 to 6 different programs or processes. If you want to tighten a specific type of bolt, you have to use process 1 and configure it in ABCD approach. But why should a customer bother about all that domain or tightening expertise? Customer will just say, I have the blueprint of the car. I need to tighten bolt 1. I don't care which process this tool needs to execute. So that's where this joint management use case is going to help. Customer will just provide the identity of the bolt, and then the underlying tool or the controller will decide what is the best or optimistic process to be executed. So this is a very minimal draft which is defined, and this will be enhanced in the future versions. So these are the primary use cases. The next step is to go through the models. I will not go through in the details about the properties, but just explain some underlying ideas and how we have utilized harmonization, which is very important for us. So if you see here, we have defined a placeholder called joining system. Joining system is not an asset. It is a collection of building blocks. So we have building blocks like asset management, result management, joining process management, joint management. And we have used base specifications like machinery, DI, asset management basics so far. Now, this is a very simple entry point, but let's go into the building blocks. So these are the asset management or the assets which we have defined within a joining system. These are the most commonly used asset. Controller and tool mostly are mandatory because we need, this tool has an embedded controller. That's why it doesn't need a separate box to control it. It has a controller inside. Apart from that, based on the type of use case, there can be, and this is stress tested, drop tested, and duration tested. So I had a real-time testing now. Yeah, so we have different assets based on different device or different configurations or use cases. But one point with respect to OPC UA is, yeah, we talk about identifying a specific device, but me personally have been participating 8 out of 10 harmonization group meetings, and we tried not to reinvent anything. Why should I define serial number property? What should be the data type? Why should I define the semantic? It is available from base specifications. So we have reused whatever available from the other base specifications like DI and machinery. But apart from that, we have also utilized a concept of OPC UA called interfaces and add-ins. Why? Right, we needed assets for these things, like cable, feeder, sensor. But is Atlas Copco a core expert in sensor? No, we utilize sensor from someone else. So what we did is we defined interfaces and add-ins. In future, if there is a new working group who defines sensor model in a much more concrete way, we will integrate that. It will not break our model. So we have defined specific profiles, units, and add-ins to ensure there is no breaking change in future. So that is a key thing which I've just wanted to highlight here by reusing the harmonization and concepts of OPC UA to be future extensible. So that is a use case about asset management. And then this is just repetition. The orange color boxes are reused from the base specifications like machinery and DI. The green color boxes are defined within the joining specification. The next use case is result management. As I said, result management or results are the most important use case in our domain because results are stored for several years. The key point which I'm trying to highlight again here is the orange color box is the harmonized part. And then the green color box are the extensions which we have added. So this slide just demonstrates the reuse of the base specifications. But in result management, structure is not the only thing. Yeah, fine, structure is defined, but how can a client access the result in a standardized way? It can be done in 3 different ways as per the specification, via method calls if interested, or via event payload, or via subscription of an address-based data variable. All 3 will have the same structure, but 3 different access mechanisms based on what a specific client supports. There are clients which doesn't support events. There are clients which doesn't support methods. So access mechanism should not restrict the structural model. So we want to decouple things. We should not define a model which is dependent on a protocol binding. So that is also very important where we decouple the responsibilities. Then the next slide describes about a concrete use case within the joining system. So we support various use cases like single result, batch result, job result. What is the difference? I have this. I'm tightening a specific bolt. Yeah, that is a single result. But let's consider a wheel. Wheel may have 6 bolts on an average. First wheel, single result. Second wheel, single result. But as a customer, I want to understand whether this wheel was successfully assembled or not. So customer is interested in the consolidated status. Those 6 tightenings were okay together or not. So that is a batch result in our domain. Similarly, there can be a complex job. Yeah, there may be a complex job saying assemble seats, assemble wheels, assemble engine. So the complex job has 3 sub-processes. So that will result in a job result. So we have utilized the same result model in a nested hierarchical way, and we have defined rules to visualize all the use cases we have within our domain. The next slide is a bit more technical. Maybe I will not go through in details, but this is how the content of the result looks like. So we have overall values, and then errors and step results. Overall values are like, it is much more technical. We have a program. There can be a torque reported for multiple steps and so on. Maximum time taken for a tightening operation, etc. Those are reported as part of overall values. And within our process, there can be multiple steps. First step, tighten to a specific angle. Second step can be tightened to a specific torque and so on. So for each step, there can be a set of values which are reported. And on the right side, we have traces. I'll show during the demonstration that every time I do a single tightening operation, there are 6,000 different samples reported per result. And all these are stored for several years, and per day there can be more than 5,000 tightenings based on a regular automobile customer on a specific tool. This is the next technical slide. As I mentioned, a job result, there can be a complex job which can have a batch or a quality process, a sub-job, etc. So the result model which we have defined covers different type of hierarchies or combinations. This is just one example. So we just try to ensure that any type of use case we have in our domain should be able to work with the existing result model. Next use case is event management. I will skip the explanation about event and condition. This is something which is defined by OPC UA. We did not define that. So event is just a transient information, and condition has a state associated with that. We can acknowledge a specific condition and so on. But the key point which we try to cover in event management is the payload, whether it is a condition or event. From a joining system, we will have a standardized payload. That is the first use case. And then second use case is also very important, where we have utilized concept called condition classes from OPC UA. This is again, we did not define that. Condition classes exist from OPC UA. The right color column or right side column is something which we have defined. And why do we need condition classes? There can be thousands of things which can be reported from a system. And client will be overwhelmed or overburdened with lot of events. Client is interested to have subset or specific type of events, and how can he filter out them? Condition classes can help out. So on the left side, those are the condition classes which are defined in the base specifications. And the right side, we have defined our own needed one. Now, if we take an example, tool disconnected, we can report the condition class, okay, it is a system-related event, and condition subclass will be asset disconnected. So we can form various combinations, and these rules are defined in the specification. So that was about event management. And then let's talk about joining process. Similar to the result model, on the left side, we see the result model, and then we have defined a joining process model. Now, joining process can be a single program, or it can be a batch process, or a job process. We have defined a one-to-one mapping so that it is very easy to map the configuration and the outcome of that. But one thing which we did not define in the specification is the definition of program. There we do not have an agreement, and also there are business reasons. This is the room for innovation where each vendor wants to have some innovation at their level. So this is something not defined as a standard. It will be a blob, a vendor-specific blob, which can be sent and received. We have defined the respective methods to send and receive or control the programs, but we did not define the definition or the content of it in the standard. The next use case is joint management. As I said, joint management is very important for our future smart factory related applications. If I have a bolt, anyone who doesn't understand the tightening industry and he wants to tighten a bolt, would that not be cool that he just comes and tighten it automatically based on the type of bolt, based on the context? If I tell the user to know, okay, you should do a specific process, check you have configured a torque of 7 Newton meter, you have configured the angle to this value and so on. That is the complexity, and if something is done wrong, then there will be problems. Quality is very important. Consider some operator did the tightening for the seat belt, and if that was not done correctly, that is safety critical joint. So these things can be handled in a much more better way with joint management use case, and this is the first version which would definitely have more improvements based on the prototypes we do on the joint. Then technically, this is the last slide where we have defined around 40 plus different commands. As I mentioned in the beginning of the presentation, we already had something called open protocol, Atlas Copco open protocol. So we tried to cover the use cases. We did not take all the things available in the open protocol as it is. We took the use cases. We have defined that in OPC UA specification in a modern way and future extensible way. So these are the list of commands, and yeah, I can't explain this for sure now. And this is a very beautiful concept or excellent concept from OPC UA. This is my personal opinion. What is profiles conformance units? I will not explain that. But if we want extensible and interoperable model, consider if we have defined a specific data type or an object type. If we say all the properties are mandatory in the model itself, and there can be diverse type of systems, then we will lose the flexibility. But if we say everything is optional, then that is also a problem. Things cannot be interoperable. So the best combination is don't restrict things at the model level. We have not restricted at model level because various systems are there. We need to have subset of data based on the type of system. But we also need rules to ensure interoperability exists. And that's where the combination of optional things in the model plus profiles help us choose the right set of systems and right level of certification. Many people doesn't have the complete understanding about the profiles, but this is a very powerful mechanism if used correctly. And then there are references, and maybe I can do a quick demonstration. Many companion specifications which are there, I guess companion specification gained popularity from 2015 or 16, and then harmonization work actually started in 2019 as far as I know. The key thing is, as an editor or as a group member, someone has to take responsibility to define or develop prototypes and simulators. This is the only way to prove things work. Because 5 years back, I always was questioned, yeah, OPC UA, right? You are working on OPC UA, that is a slow technology. Why should I use OPC UA? My existing protocol works, but how can I prove that OPC UA works? By really implementing it. So this is the first step. Just having the companion specification as a document might not help. So what we did is we published a complete reference implementation of our specification, not only server, we implemented client and server, and I will show the demonstration. So let me go to the demonstration. This is the GitHub where we have also published a complete 100-slide modular presentation. Who doesn't know OPC UA, who doesn't know companion specification, they can read about it. It's publicly available. And then we have also implemented a reference server and a reference client. Why it was important? Because customers were using traditional protocols. Yeah, it is very complex. I don't know how to consume this data. Fine. We have the demo client. It is just 20 lines of code. If you want to read the result, this is the type of algorithm. If you're using SDK 1, SDK 2, SDK 3, it doesn't matter. Understand the algorithm. In a different SDK, the API or the name of the function might be different. But algorithm is very cool. 10 lines, 20 lines to consume this data. Maybe 30 lines to consume data 2 or something like that. So that's where the client reference implementations are very important. And let me now directly show a demonstration. Left side is UA Expert. Thanks a lot to Unified Automation to have this wonderful client. This is a very stable client, which I can say. And one more thing is, when I talk about clients and making life easier for our end customers, there are some challenges also. Providers, a lot of client providers and some gateway providers doesn't support some core functionality. But when we spoke to Process, they were quick enough to support a specific functionality which we can demonstrate easily. For example, extension objects. I'm really thankful that some gateway providers are very quick in adapting that, but then there is a room for improvement for other providers as well. So let's go through the demonstration. I have this tool running, and then I will go to the reference client which I have implemented. Let me refresh this so that every data is cleared. So the right side is the reference implementation. Left side is the generic client. OPC UA server is running on the tool. And if you see, yeah, traditionally, this is not a good tightening because I'm doing a rotate operation. The torque values are just ranging from 0.01 to 0.02. So if you see, we got the complete result model here, or the result for a single one. And these are the trace samples. Traces are very important. We send around more than 5,000 samples when we do one single tightening. Why is it important? Since I did a rotate operation, I don't have a joint. I can't control this. If I do an actual tightening which is successful would look something like this. Let me simulate an actual tightening, which, so within our tightening domain, somebody who sees a graph like this will identify that this was a successful tightening. This is very important data from our domain perspective. So as I mentioned, maybe I should just try to wrap up now. These are the references. To summarize, we have the need to help our customers towards smart factory journey. And how are we doing that? With a framework called Smart Integrated Assembly. But all in all, one important thing, systems have to talk to each other. Devices have to talk to the systems and each other. How? With the standards. Which standard? In our domain, IJT standard. But is that good enough? No, harmonization is also very important. Is that still good enough? We need help from the providers. We need the OPC UA providers and different integrators to support these functionalities to make it happen. What can a working group and vendors do? Implement prototypes and so on, and publish it for public use, and show that it is not complex to implement, and it is not bad performance, where it's always a rumor. Somebody has to prove that it is not bad performance. So that's it from me. I'm sorry if I have spoken. I'm not sure how much time it took, but I guess it was good.
It's good, and that was excellent. Thank you.
Thank you.